In the limitlessness of the universe, humankind has just started to expose investigation. In spite of our restricted information, we have long considered the chance of extraterrestrial life, frequently engaging the possibility that we may be distant from everyone else in the universe. In any case, an outlook-changing occasion happened with the appearance of our most memorable interstellar guest, Oumuamua. Not at all like anything we had experienced previously, this puzzling object left us in wonder of the possibilities that lie beyond our reality. As of late, famous astrophysicist Neil deGrasse Tyson stunned the world by revealing never-before-seen declassified pictures of Oumuamua. What elements are responsible for sending this extraterrestrial courier? What is the YP impact, and what does it have to do with Oumuamua? Join us as we adventure into the depths of space, moved by the information shared by the astrophysicist. To unravel the mystery behind this peculiar interstellar voyager, it's crucial to first explore the captivating nature of this heavenly object. On October 19, 2017, astronomers at the Haleakala Observatory in Hawaii made a historic observation of what they initially believed to be a comet or a space rock. However, further examination revealed that it was, in fact, the very first interstellar object identified within our local planetary group, barring dust grains. The object's skewed circle and rapid speed led scientists to conclude that it originated from beyond our planetary system, prompting them to christen it with the Hawaiian name Oumuamua, signifying a messenger from afar. First stargazers immediately realized that Oumuamua displayed wild swings in brightness, challenging easy explanation. They soon gathered that it must have an exceptionally elongated shape, with a length 5 to 10 times greater than its width. The peculiar shape of this baffling flying object ignited numerous speculations and theories aimed at unraveling its origin and purpose. One theory suggests that Oumuamua's elongated shape might result from tidal forces when an object passes close to a star. This tidal stretching could account for Oumuamua's stretched, stogie-like appearance. However, this explanation faces challenges in explaining the specific aspects and extent observed in Oumuamua. To gain further insights into Oumuamua's shape, space experts have turned their attention to similar objects within our planetary group. One such object is the asteroid 25143 Itokawa, which was visited by the Japanese Hayabusa spacecraft in 2005. Itokawa displays an elongated shape resembling a rough diamond or a potato. Focusing on Itokawa's shape and surface features has provided valuable information about the processes involved in forming and shaping such objects. However, while Itokawa shares some similarities with Oumuamua, the interstellar visitor remains unique in its elongated extents and absence of a tail. Oumuamua's exceptional speed, which is like a bicycle suddenly gaining speed without pedaling, adds a charming element to its character. After entering our local planetary group from above the plane where planets orbit, it moved exceptionally close to the Sun, reaching around a quarter of the Earth-Sun distance. Following this close encounter, the cosmic voyager continued its trajectory below the planetary plane. It is truly surprising that Oumuamua maintained an incredibly fast speed throughout its journey. Starting at around 196,000 miles per hour, indicative of a significant amount of kinetic energy. To put this into perspective, its speed surpasses that of any human-sent object, including spacecraft and satellites. This high speed has led to the speculation that Oumuamua might have originated from a binary star system. The hypothesis suggests that gravitational interactions within binary star systems can release objects at high speeds. Assuming that Oumuamua did indeed originate from such a system, it is possible that the gravitational forces exerted by the stars pushed it on its interstellar journey, explaining its striking velocity. Another possibility suggests that Oumuamua's speed was a result of interactions with other celestial bodies in its home star system. Encounters with planets or other sizable objects might have acted as gravitational slingshots, propelling Oumuamua to its notable speed. This strategy is commonly used by space missions, utilizing the gravitational pull of planets during flybys to gain speed. However, further investigation is necessary to determine the likelihood of such encounters and their contribution to Oumuamua's speed. Beyond its speed, studies have revealed fascinating insights about Oumuamua's composition. It has a thick outer layer, like a cosmic shell, made of carbon-rich materials that set due to cosmic radiation during its extensive travels through interstellar space. Underneath this protective exterior, Oumuamua reveals its incredibly dense inner nature, primarily made up of rock and possibly containing elements of metal. What sets it apart is the absence of water or ice, which distinguishes it from typical comets or icy celestial bodies. Additionally, Oumuamua's surface has a reddish color resulting from prolonged exposure to cosmic rays over millions of years. Researchers have likewise considered the likelihood that Oumuamua's rapidity is a result of its shape and organization. Then again, some people have mentioned the contribution of famous specialists like Neil deGrasse Tyson and Michio Kaku in the conversation around Oumuamua. Strangely, Neil deGrasse Tyson avoided commenting on this issue until significant evidence and the newly declassified photographs became available, leaving everybody anxiously awaiting his viewpoint on the matter. Some scientists suggest that the object's elongated structure, as derived from its light bend, shows that it may be a part of a larger body. Assuming Oumuamua severed from a larger object due to a crash or other rough events, it could have gained significant speed during the detachment process. This would suggest that Oumuamua's speed isn't characteristic of its inclination, but rather a consequence of previous events. Comets, for example, cross our planetary group at different speeds. While certain comets can achieve speed similar to Oumuamua's, they typically display leftover gas and residue due to their predictable arrangement. Interestingly, Oumuamua showed no such attributes, distinguishing it from known cometary articles. Another comparison can be made with asteroids, rocky objects that circle the Sun. Most asteroids in our planetary group move at substantially slower paces than Oumuamua. This divergence underscores the outstanding nature of Oumuamua's speed and its differentiation from typical nearby planetary group objects. Here's where things become much more interesting. A few specialists hypothesize that Oumuamua could be more than a naturally occurring object. They propose that it could be an artificially created creation, fastidiously made by a high-level extraterrestrial human advancement. Outsiders could be part of an extremely advanced alien spaceship or equipment designed for exploration. As indicated by this hypothesis, Oumuamua's special elements could serve multiple functions. Its elongated structure could improve its flexibility during interstellar travel, while its propulsion system could enable precise maneuvering through the cosmos. Popular figures like Avi Loeb, an Israeli-American theoretical physicist and astronomer, strongly believe in this theory. Loeb even proposed a controversial hypothesis that Oumuamua could be of extraterrestrial origin, suggesting that it could be an artificial object or even a piece of alien technology. His hypothesis generated widespread discussion and debate within the scientific community. Nonetheless, it is essential to note that many researchers and space experts have expressed doubt about his claims. The common view among most researchers is that Oumuamua is probably a natural object like a comet or a space rock, with its surprising properties being the consequence of regular cycles. Wesley C. Fraser and other scientists combined brilliance estimations from various telescopes to examine its rotation period. They concluded that no revolution period can account for the observed brilliance variations. Instead, the article seems to be tumbling in an excited rotational express. This strange, unconventional tumbling movement was unlike anything seen previously. Observations made by space experts have given valuable insights into Oumuamua's twist. It completes a full turn every 7.3 hours, which is relatively quick compared to the rotational times of other articles in our nearby planetary group. Moreover, its brilliance shifts significantly as it turns, indicating that different parts of the article reflect sunlight to changing degrees. This irregular rotation has baffled researchers and prompted various interesting speculations. One hypothesis proposed to make sense of Oumuamua's twist is the turn-initiated outgassing hypothesis. According to this idea, unstable substances underneath its surface are exposed to solar radiation as the article tumbles through space, causing it to decompose and create small gas jets. These jets act as engines, imparting a force on Oumuamua and causing it to tumble erratically. This suggests that Oumuamua's structure might contain unstable material susceptible to sublimation, influenced by solar radiation. However, further examinations are needed to confirm if this mechanism is responsible for Oumuamua's curious rotation. Another hypothesis proposes that Oumuamua's tumbling movement could result from an earlier impact with another object. It is possible that a rapid impact distorted its shape and set it into an unpredictable twist. This impact could have occurred in the object's home star system prior to being catapulted into interstellar space. However, the exact nature of such an impact and the objects involved remain speculative due to limited observational data. Detailed examination of Oumuamua's shape, composition, and surface features could provide clues supporting this hypothesis. To better contextualize Oumuamua's unique development, let's look at other heavenly articles with similar ways of behaving. One such article is the asteroid 4179 Tutatis. This elongated space rock discovered in 1989 displays a tumbling movement much like Oumuamua. Researchers have proposed several hypotheses to make sense of Tutatis's whims.